Hello, everybody. We're looking at 13.5 day 1, okay? And what we're basically going to be doing is graphing what are called the reciprocal functions. So our secant and our cosecant, okay? So our basic equation is, again, this y equals k plus a times, I'm going to put trig there, okay? Because that could mean sine, cosine, tangent, cosecant, secant, cotangent. Any of those can go right there, okay? But the equation stays the same. Then we have our b and then the x minus h. P is going to be still 2 pi over b, okay? Where each notch after h is the period over 4, okay? So everything we learned in those last lessons are all going to work the same. Here's what we're going to do. When we graph a cosecant, we are going to graph a sine curve and then flip it over. And let me show you how that's done. Okay, so when I start out on any of these, I don't even care what that is. Okay, I still need to find my K, my H, my A, my B, my period, and each notch. No matter what this says, okay? I can look at that way after I even set up my graph. So let's take a look at how we go about this. Okay, I'm going to get in here and bring that down there. Okay, so my K is 3. My H is 1, right? Opposite of what you see there. The A is 2, amplitude, okay? My B is pi over 6. And my period is, again, always going to be 2 pi over B, which here equals 2 pi over 6. We flip and multiply. 2 pi times 6 over pi. The pi's cancel. Whack, whack. Let's see. Oh, it's not letting me go over. Okay, yeah, it is letting me go over. And then that equals 12. Okay? Then I go to each notch, and that is my period divided by 4. So my period equals 12, so I got 12 divided by 4, so I've got 3. Okay, that's the information I need to have to set up my graph. No matter what I'm dealing with, whether I'm dealing with the sine, cosine, or secant or cosecant. Okay, I'm going to erase this, how I got to 12 and how I got to 3, just so I have enough room to graph. Okay, but I hope that math is getting easy for us as we keep using it. All right, let's see here. So that was 12, and then that was 3. Okay, so I'm going to set up my graph. Always the same way. Boom, right here. Okay, and then I look at K, and then that adjusts my x-axis. So I'm going to bring this down there. Okay, because my K is at 3, so I'm going to go 3. And then K plus A is at 5, and K minus A is at 1, right? And I actually like to label those. So let's see if I can do that and make it look okay. Not like that. Bring this down. Call this K plus A right there. Bring this thing down here. And that is K equals 3. And then bring this thing down here. And that is, where am I going to do that one? Let's go K minus A equals, head it over there. Okay, so anyway, that's how I set it up. I wish I had a little more room. Wish I had a big old chalkboard that I could work on. Anyway, here we go. Now we're going to set up our H and then our 4 notches after that. Okay, H is at 1. Nice and easy. 1. And then after that, I just go 1, 2, 3, 4. And I make them all about the same length apart. Okay, they should all be the same length apart. Okay, each notch is 3, and that is after H. So I go 1 plus 3 gives me 4, and then plus 3 is 7, plus 3 is 10, plus 3 is 13. I like to dash my K right there. Okay, now I have my graph set up. This is how I'd set up any of the 4 graphs. Actually, any of the 6 graphs, really. So when we're looking at this, I'm looking at a cosecant. The cosecant is the reciprocal of the sine, right? So what I like to do when I do this is put a little like, okay, this is actually like graphing a sine, okay? And I'm actually going to graph a sine curve, okay? But I'm going to do it dashed instead of solid. And I'm going to switch. I might as well try to use some technology here, okay? I'm going to use this red, and I'm going to dash this sine curve, okay? Sine curve, and we're positive, so I start at HK like every sine curve does. Then I go up to the top, middle, bottom, back to middle, okay? I'm going to graph this. I'm going to graph it dash because I'm not actually graphing this. I am going to graph a cosecant. Now, how do I do that? How I do that is this. I'm going to switch this to black again because now I'm actually going to graph my cosecant. Okay, so the zeros, or where it hits the midline or the K, is going to turn into vertical asymptotes. Okay, so I'm going to have vertical asymptotes like this, and like that. Okay, right where it hits the midline, right where it hits K. Then I'm going to go to this top here, and I'm just going to take that and do the reciprocal. Flip it up. Go to the bottom here, flip it down. And there it is. Right here and here, I have graphed one period of a cosecant. Okay? And you might ask why it works that way. So let's take a look at that real quick. Okay. I'm going to go like here. Oh, no, I want just a new page. Can I do that? There we go, new page. Okay, so why does it work that way? Well, let's take a look. I'm going to just do a circle. Okay, and I'm going to call this a unit circle. So I'm going to do my line through it, right? And line through it. Hopefully it works out okay. Oop, there we go. Close enough. Okay, so on my unit circle, if I did a sine, I would be talking about the y values. So I'd be talking 0, 1, 0, -1. Okay? Now, if I'm going to be doing a cosecant, wow, that was a terrible circle, and they saved me. Okay? All I'm going to do is take these and take the reciprocal of them. Well, the reciprocal is the same thing as putting something under 1. So, like, for example, the reciprocal of 2 is 1 over 2, or 1/2. Okay? So, on these, this would just become 1 over 1. And this would become -1 over 1. Now, the problem is this would become 1 over 0. And this would become 1 over 0. Now, what's the deal with the 1 over 0? That is an undefined, not real number. Okay? So what we do where we have the undefined, not real numbers is we switch those to be vertical asymptotes on a graph because they don't actually exist. Okay? Undefined. So we build basically this wall, which is called a vertical asymptote. Okay. I'm going to go back to the notes that we have. Okay? That is why, because we're dealing with the reciprocal of what our 0 would be if it got shifted up, right? Reciprocal of 0 is a vertical asymptote. So that's why the vertical asymptotes go at the zeros. Okay, so I'm going to do one more, and then I think I'm going to stop talking. All right, let's move this thing up, clear out a little room. All right, let's go. The K here is 2. The h is pi, opposite of what we see. The amplitude is 4. Now, some of you might be saying, hey, that's negative 4. The amplitude is an absolute value, okay? That negative is going to tell us what direction we graph in, okay? So it's going to graph from the bottom to the top because it's a reciprocal of a cosine. We'll get there in a second. All right, b is 1/2. Always notice that the h and the b are in different forms. One of them will have pi in it, one of them won't. And that's how it's going to work for this stuff. All right, the period, 2 pi over b. Flip it. Four pi. Okay. Each notch, 4 pi, period, over 4. So each notch is going to be pi. Okay, should be pretty simple because what is going to happen here with the math that we do, if you'll notice, our each notch, sorry, let me get rid of this. Our each notch and our h are always going to be in the same terms. For example, up here, our each notch was in normal numbers, and our h was in normal numbers. Down here, our each notch is in terms of pi, and our h is in terms of pi. Okay, again, I'm going to erase this so I have room to work, and I'm going to put the 4 pi next to it. Okay, here we go. Where's my k? At 2. Where's my a? At 4. Okay, well, I'm going to slide this down slightly right there. Extend it because I always have trouble keeping it inside. Okay, now my k is at 2. I'm going to do it this way. Yeah, that's okay. All right, my k plus a, so that's plus 4. So I'm going to call it up here. That should kind of work for it. So k plus a equals 4 plus 2 is 6. And then I'm going to go down, right? Because my k minus a, so that's 2 minus 4, that's going to get me at negative 2. So I'm going to put that, let's get that lower. Bang, right there. Let's call that negative 2 and go negative 2 and then call that k minus a. All right? Okay, so we've set up our y. Now we set up our x. We're starting at pi. We'll just call it, bang, right there. That's h. Okay, and then 1, 2, 3, 4. Okay, so that is going to be pi. I want to get this in there. That's going to be pi, and then add pi, so that's 2 pi, and then we're at 3 pi, and then, let's see if it slides over here. Then we're at 4 pi. Okay, so that is, those are our x values as we went. 1, 2, 3, 4, we need one more, right? Slide this thing over. It's not working for me. I'll just do it here. 5 pi is our last one, right? Okay, so I've set that up. That graph should get pretty easy for us to do, okay, given how many times we do it, and we do the same for every one of them. Okay, now I look at what I'm dealing with on the equation. I'm dealing with the secant, which is the reciprocal of a cosine. So I'm going to graph a cosine, dashed. I'll make it red because why not? Okay, cosine, negative cosine. So I start at h and then k minus a. So down here at the bottom. And then, oh, I forgot to dash my midline. I'm going to do that in red. Dash. Okay. And then I go up to here, and then up to the top, and then down to the middle, and then down to the bottom. And now what I got to do is make sure that I'm curving this, that I don't make it look just like a V. I'm actually going to curve this, and I'm going to dash it because I'm not really graphing a cosine. I'm going to graph a secant. Oh, that's terrible. Okay, secant. Boom, 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 up here like that, in red. Dashed, because it's actually not there. It's just going to guide our graph. Okay, now what do we do on all of these? We change where it hits the midline into vertical asymptotes. So it hits the midline right here. Okay, we're going to make vertical asymptotes through the 2 pi and the 4 pi. Then we're going to flip our tops and our bottoms where it hits the asymptote. So I go there and I flip it down. Okay, go here, flip it up. Go here and flip it down. Now that's 1 period. If you want to do the other side of that, you're going beyond 1 period. I'm fine with that. Okay, so that's what a secant is going to look like. Okay, pretty straightforward. If you get comfortable and understand what you're doing here, they're all going to look like this, right? Take a look at that. Boom. Where do you draw your asymptotes? Where it hits K. Boom, asymptotes, asymptotes, asymptotes. Highlight the top, flip it up, highlight the bottom, flip it down. Okay, same deal here, right? We have a cosine. This one's a positive cosine, or a positive secant. We graph a positive cosine, and we just go from the top to the bottom, up to the top, right? Where does the vertical asymptote go? It goes right where it hits the 0, okay, or the K, or the midline, all synonymous, same thing, okay? Highlight it, flip it, highlight it, flip it up, flip it up. If you want to graph the other side of that, I'm fine with that. Okay, awesome. Homework 1 through 4. I have it laid out on a separate thing that you can just PDF, and it's set up with our kind of system here with the K, H, A, B, P each notch, and go ahead and get after it. Thank you. See ya.